makes sense.
Mm-hmm.
And I'll edit out everything.
All the expletives, even though they're the best part.
I definitely not edit out the expletives.
Oh.
But I'll edit out what we're doing right now.
This is also the best part, though.
Maybe I'll keep it then. I don't know. I'd love for this to be more conversational than it has been so far.
Mm-hmm.
Obviously, when you're all by yourself, it's hard to be conversational.
It is.
But, at the same time, I want to keep it under 10 minutes, and I also want, to actually say stuff, right? This isn't like always sunny, right? Like, people aren't tuning in just to listen to me.
Maybe they are.
I doubt it.
Hmm.
All right. Welcome to Church of Logic. I'm Cody Rue, and I'm here with Phil Zucker. And today, I guess we're going to talk about Datalog. All right. So, what is Datalog?
A good question.
This is, Church of Logic. I want to talk about logical aspects of things. So, what's a logical, a logician's definition of Datalog? What would that be?
So, Datalog is, or at least has a lot of appearance of a subset of first-order logic. In particular, you don't allow, in traditional Datalog, you don't allow function symbols, is one thing. And also, everything is in the form of horn clauses, which are universally quantified statements with an implication, and you allow only conjunction in the hypothesis of the implication and also in the conclusion.
Okay, so for all x, and then a and b and c implies d. All right, cool.
And this is a very interesting fragment because it has a lot of special properties, in particular operational properties and applications. It has a strong relationship to the world of databases. You can sort of describe databases by sort of initializing a database with facts using logical statements to state those facts, and then you have these for all statements or these implication horn clauses.
Okay. Can you just give me an example, maybe?
Well, I think the canonical Datalog example is the edge path problem. You can state a bunch of edges using first-order logic, that there's a graph with edge between 1 and 2, an edge between 2 and 3, an edge between 3 and 4.
Okay, but I think I've heard traditionally the parent-grandparent relation.
Sure.
So let's say you want to describe a database with all the ancestor relations.
Mm-hmm.
So how would you do that? What would your atoms be that you seed it with, and what would these facts be that you learn?
Right. So you could start with facts or atoms, one per person, and then you could have a parent relation that relates two different people. And then the question is that the interesting bit of the example is you want to ask about ancestors, which is a transitive property of this parent relation. So operationally, what you could do is you could instantiate a database with the parent relation, and then you define this rule that can start iteratively building up the ancestor relation out of this parent relation, but also the previous iteration of the ancestor relation.
Right. So parent XY and ancestor YZ implies ancestor XZ. Is that right?
Mm-hmm.
All right. And so what's the database that you're describing here? Is it it's everything, right? It's all the people and all the relationships, the parent and the ancestor relationships. That's
Yes.
the database
So
you're talking about.
it's two tables, one parent table and one ancestor table.
Okay. And what? Okay, so you talked about this already, but we didn't nail down. So you said the operational properties of this are interesting. So what's the difference between Datalog in terms of describing tables and say all first order logic, right? What's good about Datalog?
Well, Datalog has a very simple procedure to start building this database, this model of these first order logical sentences. If you had arbitrary, more complicated first order logic that has nested quantifiers and things, then building a model of a bunch of first order logic statements is a very challenging problem. That's what theorem provers, first order logic theorem provers are designed to do in some cases. But the data log is such a restricted language that there's a very simple operational procedure where you initialize the database and you just start growing it and growing it and growing it. And because of the constraints of the language, you're guaranteed that this growing process terminates and actually terminates fairly quickly.
Okay. So in first order logic, this process is still theoretically possible, but it doesn't necessarily terminate.
It's not, I don't know of how you would I don't know how you would iteratively grow a model to try and fit an arbitrary set of first order logic statements. Maybe you can do that.
Sorry about the dog. Yeah, I mean, I'm sure you could, right? You could Scolomize, right, and then you could build the Herbrand model, or Herbrandize, I guess would be the word.
Well, in first order logic, you'd have disjunction. Things wouldn't be in horn clauses. So
Sure.
it's what would be the things I would take as my initial database? Just an empty one, I guess, or
Sure. I think it's like it's like for Datalog, right? Each atom in Datalog can be seen as this kind of trivial horn clause of like no hypotheses and no modified variables.
So just okay, so just the fact you're assuming you still have facts, but now you want arbitrary first order logic,
right?
Axioms, I guess, also.
But I don't want to get too off track. I think that the idea that you can build these models in a nice way, in a nice algorithmic way, is essential to the Datalog philosophy. Like why we care about Datalog. Do you happen to know what the algorithmic complexity of this is?
Well, it's famously supposed to be polynomial time. I don't know.
The size of.
Probably the size of the initial database.
Is that true? You can't have things that end up being exponentially big compared to the initial atoms. I'll believe you. I actually have no idea.
Oh, I have no idea either. So that's why it's good for a podcast.
Yeah.
Polynomial time in what? In the number of
time.
It could only be the number of rules or the size of the initial database. What else can you talk about?
It's definitely at least the size of the initial database, right? Because just crawling over that thing could be much slower than. You could have one rule, but your database is huge, so it has to be at least in that size. I suspect that you're right. It's polynomial in that size, which of course, again, can be huge, right? N squared over a real database is like not okay.
Yeah.
But still, Datalog is powerful, and so maybe it is okay if you want something as powerful as Datalog. Can you talk about?
Could be the number of atoms also.
Yeah.
That would probably be pretty. That's kind of an essential point that there's a finite number of atoms. It's sort of why the thing works, I think.
And atoms are initial constants in your model or
Mm-hmm.
all constants in your model?
There's only, you don't make new atoms in
Okay.
typical Datalog.
I see.
That's, you're lacking function symbols, so really that's why you can't make new atoms.
Cool. All right, can you talk about SQL? I mean, I'm prompting you a little bit here, but SQL obviously is also kind of somehow related to logic. And
Yeah.
also related to databases. And some people call it SQL, I guess.
Mm-hmm.
So yeah, what's up with SQL versus Datalog?
Yeah, so SQL is a language for describing controlling databases, typically querying databases, but also inserting, updating, deleting rows from the table according to different criteria. And it's a declarative language for the most part. It's describing what you want and not how to do it per se, although this insert, update, and delete stuff certainly has a what I want to happen flavor to it. And so one perception of what Datalog is a more traditional, logically flavored version of SQL. Um, its syntax looks more like traditional logical syntax. And
Are there things you can do in SQL that you can't in Datalog, other than the inserts, say?
yeah, I mean, SQL, SQL, I mean, exactly that, the inserts, the updates, and deletes. And also, there's some interesting stuff in SQL. There's these group by operations, which is really not in simple data log clear how to do that.
Okay.
And the big thing that Datalog does have is this recursion aspect to it, that you can describe this rule to how to build a database, and it like iteratively builds the thing. And you actually can do that in SQL too, although it's a pain. There's this thing called recursive common table expressions.
Right. So SQL is not really one language, right? It's half a dozen at least.
Yeah, it's a pretty decently sized language, whereas Datalog has traditional Datalog has pretty small number of concepts.
Okay, so traditional Datalog has this recursive aspect where you can talk about ancestors,
Mm-hmm.
whereas traditional SQL doesn't really even have that.
Right.
But you're saying modern SQL does absolutely include those extensions.
Yeah, I think that's probably fairly accurate.
Okay, but in a messier way.
Oh, it's super messy. Like I've done it just to make sure that I understood how to do like this parent ancestor problem in SQL, and it's ugly. Although that's subjective. I mean, if you're more used to SQL, I'm sure you'd be like, this is fine.
All right, we're time's flying. Are there like just like slam dunk cool applications of Datalog that you want to mention? We can talk about them later, but that you just want to like tease people.
I mean, the thing that it gets a lot of play for is program analysis problems. Um, you can build program analyses, which are some kind of fixed point operation, some kind of yeah.
Right. So okay, let me prompt you a little more. All right. So like, say you want to build the set of live variables at a point.
Mm-hmm.
Like, does how does Datalog allow you to express this in a nice way?
So a lot of program analyses are this iterative process where they use these like sets or things growing at each program point of like, for example, as you mentioned, live variables. The live variables might be growing or shrinking depending on how that one works exactly.
Right. So you could have rules that say, okay, well, given my knowledge at the current moment, I know that this variable must be live, or I know this variable must not be live.
Yeah.
At this point, and then the iteration, the execution of the Datalog program, is going to eventually compute that set that you actually want.
Right.
Okay, cool. That is a very nice application. I think we're about at time, but let's try and revisit this and like talk about the details.
Okay.
All right, neat.